Once again, good morning, students. I would invite Prachi ma'am to start the session.
Hello everyone, good morning. How are you all? So, yes, we have Bhavna, Akshaya, Shravani, Ashrita, right? So, yes, how are you all?
Fine,
And
ma'am.
okay, and did you do the revision of whatever we have done till now? Yes, that is more important. Did you do the revision? And the other important thing is I provided some questions, right? How many of you have attempted those questions? Because I think I just got answer to one question and it is from whom I don't know. But yeah, I don't think others have tried the questions.
It is
So yeah,
from Bhavna madam.
okay, yeah, Bhavna, there were other questions also. What about those? And what about others? Why didn't you try the questions and send the answer? Okay, tell me. Yes, Shravani, did you try the questions that were given to you? So Shravani was there in the class last time. Ashrita was there, I guess. Bhavna was there. Akshaya, I don't know, was there in last class or not. But yes, quickly tell me, did you try those questions and then we'll begin with our lesson.
Yes, ma'am, I tried, but it's correct or not, I don't know.
Okay, you tried. So don't worry about that, but at least whatever you have tried, just send it to ma'am. Why you have to worry about that? Obviously, you have learned something. So let's see how are you able to apply it. Getting the correct answer is the other thing, but yes, first step is to try all the questions based on whatever you have understood, right? So from next time, I want answers from everyone. This should not be the case. Otherwise, I won't continue the class. Then in this way, you will have so many backlogs, right? So many questions, so many concepts in which you will have confusion, right? So let's see what where we are in this chapter, which is the structure of atom, right? Now you all have to help me with writing whatever we have learned. So in this, we are learning about the atomic models, right? So what was the first model that we learned about?
J.J. Thomson model.
Yes, J.J. Thomson model. And he was the one who discovered electron, right?
Yes, ma'am.
So once he discovered the electron, he thought, okay, let's give an model. And his model is also known as plum, pudding, raisin, or watermelon model, right?
Yes,
Hmm. Now, the next, with the help of the gold foil experiment, Rutherford,
the third model.
yeah, he came up with his model. And yes, according to Thomson, atom would look something like this. You will have electron and you will have the matrix here, right? According to him, there you will have a nucleus which is very small and the radius of nucleus will be 10 raised to the power minus 15 meters. And then around that you have the electrons. Now, the third model is Bohr's model. And the fourth one that we will learn and the last one is quantum mechanical model, right? Now, before we went to the Bohr's model, what are the things that we learned about? Hmm. So what were the developments that we learned about? Or what were the developments that the Bohr considered before giving his model? Now, from here, yes, the important things they start from here, which is the developments that leads to the Bohr model of atom. Yes, what is the first one? You must remember the sequence like this, how I am writing. Okay. So in this, up till here, it's fine. But yeah, these information you should remember what is the radius of the nucleus. And then, yes, from Bohr's model and the developments that is leading to the Bohr model, those are important. So quickly tell me, okay, Gayatri is saying stability of atom. No, see, understand the question. What I am asking is, what were those, what we say, discoveries or the observations or the developments which Bohr considered, and then he improved the Rutherford model to give his model, which is the Bohr's atomic model. If you'll forget like this, then it will become very, very difficult for you to.
Electron is revolved around the
Yes, what were the developments? Developments, I'm not asking about what are the postulates. And I have been very clear throughout my classes about the developments and about the segregation of topics, right? This thing, I was very specific. What were the two developments? Yes, Bhavna says, okay. So the, oh my God. Yes. So, yes, he studied the line spectra of elements, right? And whatever he saw in that, and according to that, he improved the Rutherford model. What was the first thing? This time I will not answer this, okay? First thing, you people are not sending the answer, and then the other thing is you're not even remembering what is in your notebook at least. Just go through your notebook. It won't take much time, right? It will take you just 1 or 2 minutes. Quickly tell me what was the first development.
photo electron.
Uh, what is it? Energy is quantized. See, understand the question. Don't just give some random answers which you remember. Right now, what I am asking you, what are the things, what are the experiments which he considered? And then, yes, this is the statement that he gave once he considered those experiments, that energy is quantized. Right? First, understand the question that I'm asking. What I'm asking, what are those things which he considered before giving his model, or we say before improving the Rutherford model? What are those experiments? What are those things which he considered before giving his model, right? So that you have to answer. So wake up, turn your pages, answer this. I hope you are making the notes, right? Or are you just coming to the class, listening to it and going? You're sitting with your notebook, pen, and everything, right? Okay, first tell me how many of you are maintaining the notes? Now, See, I have given you the notes in like a proper sequence. Right now, quickly tell me how many of you are maintaining the notes. Because the model that we have to learn next is much more complicated than, or is not that easy to digest or accept or understand, right? Yes, what about others? Yeah, Bhavna is constantly responding. She says hydrogen spectrum, black body radiations. Yes. So, what were the development that led to the Bohr model? What did we learn in that? Black body radiation is one of the things that he considered. So, the first thing that he considered is the dual nature of electromagnetic radiations. That's how you have to remember this. The first development was the dual nature, and the second was the line spectra of elements. Now, in dual nature, what we say that electromagnetic radiation, which we learned the whole spectra, first comes the gamma rays, right? And what is the last one? Yes, now tell me what are the electromagnetic radiation that we have in the electromagnetic spectrum. So we have gamma rays. After that, what do we have? Hmm. Radar rays are nothing, Bhavna. Yes. In the electromagnetic radiations, we have different types of radiations, right? What are those? I can see none of you remember any of whatever we have learned in the previous classes, right? Okay. So we have gamma rays. You must remember all this, right? What do we have in the electromagnetic spectrum? These are very crucial things which you must keep in mind, right? So quickly tell me, what do we have in the spectrum of electromagnetic radiation? Yes, after gamma rays, we have UV, and between gamma and UV, what do we have? Okay, now what you do is I'll name you and you unmute yourself and tell me the answer. Okay. I hope you all have your notebooks. Otherwise, it will take a lot of time. Okay. Okay, Ashrita, tell me what are the radiations do we have in the electromagnetic radiations? Tell me in the sequence starting from gamma rays. Hmm. Yes, Ashrita. If this will go like this, I don't know how will you do the questions and everything. Hmm. Shravani. Hmm. After gamma rays, what are the radiations we have in the spectrum? Omkar. I hope you have your textbooks with you. I hope you have your notebooks with you. At least you can refer them, right? Hmm. Yes, Omkar.
UV rays, ma'am.
What do we have after gamma rays?
UV rays.
Okay, we have UV here. Now between gamma and UV, what are the other radiations?
Ultraviolet.
X-rays, ma'am. X-ray.
Okay. Okay. Now one by one. Okay. Who was this? Now, okay. Now, Omkar, you can mute yourself. Now, Bhavna, yes. What do we have after UV?
Visible. Thermal.
Visible.
Visible.
Okay, good. Gayatri, yes, you can mute yourself now. Gayatri, what do we have after visible?
Radio waves.
Radios are here. Okay.
Infrared, ma'am. After visible.
Yes.
Microwaves, ma'am.
Ah. Now, is the spectrum complete?
Yes, ma'am.
Yes, the spectrum is complete now. Now, what should we know about this spectrum? As I am going from gamma rays to radio waves, what happens to energy? What happens to... So let's put this heading somewhere down once we are on it. Okay. What about lambda and what about mu? Right? So,
Lambda increase.
mhm.
Wavelength, ma'am. Lambda.
Lambda will increase, ma'am.
Frequency.
Frequency will decrease.
Okay, one by one. Okay. Okay. Okay, Akshaya, you can tell me what happens to energy as I'm going from gamma to radio? Will it increase or will it decrease? What will happen to it? Okay, you can reply in chat if you are not having signals. Okay. Hmm. Yes, Ashrita, what will happen to energy when I am moving from gamma rays to radio? If you are not able to unmute yourself, you can reply in the chat, right? So by that time, we'll ask Omkar. Yes, Omkar, what will happen to energy? See, revision is must. That's the backbone of everything, whatever you are learning. Understanding is one part, but remembering it is the most important part, right? Now you can examine yourself how much you remember and what you are remembering. Is it in the sequence or is it correct or not? Right? So, yes, check is also important. So, yes, Bhavna, what will happen to energy?
Decrease, ma'am.
Yes, it will decrease. So all of you have to answer the same way. Be very quick. Now, Gayatri, tell me about the wavelength. So if any of you is not able to unmute yourself, you can answer in the chat. Yes, you have answered in the chat. So yes, Ashrita says it increases. Who increases? Ashrita, energy, wavelength or frequency. Now, wavelength. Wavelength will increase, yes. So, and energy will increase, which is not right, Omkar. Frequency will decrease.
Yes, ma'am.
Yes, frequency will decrease, right? So, this you must imprint in your mind because, yes, you can get questions from here. Very simple questions, which won't take you like more than 5 seconds to answer, right? So from here, when we were learning about the wave nature, now we say that it behaves as wave and it also behave as particle, right? So in this, we learned how is energy. So now we say that all the radiations which are coming, which are coming from the sun, they will have all of these, right? It will have gamma, UV, visible, IR, micro, X-ray, right? Now we said, okay, these are acting like a wave. So when we were learning about the wave, we learned that the electromagnetic radiation, they move with the speed c, and speed is related to wavelength and frequency, right? This is the formula that we learned, where c is, what is the value of c?
Speed of light, ma'am. C.
What is the speed of light?
Vacuum.
3 into
3 into
Hmm.
10 to the power of 8 meter per second.
meter.
Yeah. Now I hope you can write it. Now, then we learned about two things, two experiments which there were two things which were not able to explain by taking EM, or we say electromagnetic radiations as wave. What were those? First one is the black body radiation,
Radiation.
right? And the second one was photo.
Electric
Photo
effect.
Yes.
Electric radiation.
Now in black body radiation, who explained this? Planck, right? So in this, we got the Planck quantum,
Quantum theory.
right? Now, what is important for us from exam perspectives? That what is the formula that he gave? So he gave the formula for the energy, where what he said?
E is equal to H mu.
Yes,
Is equal to H into mu.
E is equals to H.
H. mu.
Where nu is the frequency and H is,
Planck's constant.
yes, Planck's constant. And I hope you all know the value for this.
6.626 into
Hmm.
10 to the
of minus 34 joule second.
Yes, unit. Again, I'm saying the only thing that will puzzle you in the exam are the units. So be very careful with the units, okay? Now, did we learn anything else? Any other formula in this? No, right? Now, in the photoelectric effect, what did we learn? Now, also it can be written as, so you must keep all the things at one place. So E is equals to Hc over lambda. That's how we can write it, right? Now, in the photoelectric effect, what did we learn? We learned that if I have any metal surface and electromagnetic radiations are coming, then what they observed is that there is some minimum frequency of radiation which is required for the emission of electrons, right? Correct?
Yes, ma'am.
Yes. And whatever X, so let's suppose these radiations, they are coming with the energy of H nu, and the minimum frequency that is required is H nu naught. And so what he said is, Einstein, how did he explain? So he said H nu, whatever energy that is coming, first it will be used for the emission of electron, and whatever extra energy we have, it will be used for increasing the kinetic energy. So this is the formula you must keep in mind. What are the things that you should know? This is the threshold energy, or what do we call it? And nu naught is threshold frequency, and this threshold energy is also known as work function of any metal, right? So this is known as work function W naught. Is this clear? This is clear, right? This we have already learned, but you should know what are the formulas that we have learned till now, right? Shall we move ahead?
Yes, ma'am.
Yes. Then this was all about the dual nature of electromagnetic radiation, and this is how the picture look like in the summary. That is, you must know From where did we get this formula, which is E is equals to h nu? This we got when Planck he considered the light as a particle. What he considered light as a particle. And then you must know what are all the things we learned in the photoelectric effect. What did we learn? We learned that yes, we require a minimum frequency. For example, let's suppose if I radiate potassium, if I take potassium and I radiate it with the red light, then nothing will happen, right? But if I radiate it with yellow light, if I radiate it with the yellow light, even if the light is very dim, still there will be ejection of 1 or 2 electrons. Now, as I increase the intensity, this should be very clear. Intensity only affects the number of electrons that will be released from the metal surface. So as I am increasing the intensity of light, the number of electrons that will be if that will be emitted will increase. And kinetic energy, it is proportional to the frequency of light. So one other thing which you can get in a form of statement. So the similar kind of question I gave you where you were given 4 statements, right? So yes, you can get same kind of question. So here we can say kinetic energy is proportional to the frequency of light which is falling on it, and your number of electrons that is ejected, they are proportional to intensity of light. Anything else anybody wants to add here? Yes. Nothing? You all are there, right? So let's learn about let's revise the next thing. What we learned? We learned about the spectrum, right?
Yes, mom.
We learned about the line spectrum. And basically, we learned there that we can have 2 types of spectrum. One is the absorption and other one is the emission spectrum. For us, the formulas are more important. So in this portion, we have learned lot of formulas, right? In this portion, we learned about lot of formulas. First thing that you have to remember is about the Limer, Balmer, Paschen and Fund series. What you have to remember? Limer, Balmer, Paschen, bracket and Fund.
And
And then you have Humphrey, which nobody will be asking you about. Now you quickly tell me what is the value of N1 here for Lyman. Type your answers very quick. Be very quick, okay? Lyman, it is the level on which the electron will fall. So you can quickly type your answer there. Everyone, I want answer from everyone who is there in the class. Okay, so for Lyman, the value of N1 is? Be very quick, fast, 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 fast. 1. Okay. Yes. What about others? 1. I hope Bhavna, Shravani, Ashrita, yes, all are there in the class, right? Akshaya, yeah, all are there. So you should also answer. And what is the value of Balmer? Then it will be 2, 3, 4, and 5, right? Then you know what is N2. What is N2 here? It may start from 2, 3, 4, and so on. For it, it will start from 4, 5, 6, and so on. 4, 5, 6, 5, 6, 7, 6, 7, 8. Right? Now tell me the region. Tell me the spectral region. Yes, 3, 4, 5, 6, 7. Right, Ashrita? Now tell me the spectral region for Lyman series. Yes, Lyman is UV. This you all
UV
remember.
is in
Yes, and Balmer is
visible.
yes. Then the next one, Passion,
Al
IR.
IR.
Yes, this is also IR and this is also IR, right? So yes, you can get a question from here. Also, the other kind of question that you may get is what is the longest and the shortest wavelength for Lyman series, right? So there can be for any series you can get it. So I'll tell you just one. So Lyman, so electron is falling on n equals to 1, right? Now it can come to the nearest level is n equals to 2 and the farthest one will be n equals to infinity, right? Now which transition will have a longer wavelength? 2 to 1 or infinity to 1?
Infinity to 1.
Longer wavelength. When somebody says longer wavelength, then energy is shorter wavelength. Longer wavelength. See what's the relation between energy. So you won't get direct questions, okay? E is equals to hc over lambda. So lambda is inversely proportional to energy. When I say longer wavelength, so you have to look at the transition which will be having smaller energy, right? Correct? Am I correct? So these kind of a question you can get any of in any of the series. They will ask you what will be the energy for or what will be the energy for the longer wavelength radiation for the Lyman series, right? I'll give you some questions related to that. So which one will have a longer wavelength with the one which is having smaller energy? So this will have smaller energy and this will have the higher energy, right? So they can ask you anything, what is the wave number or the wavelength for the longer wavelength radiations for the Lyman series. Okay, correct? So for longer ones, simply for this, you know, the nearest level can be 2 and the farthest can be infinity. So the one with the smaller energy will be the transition from 2 to 1
One.
and infinity to 1. I hope you can. Uh, I'll give you one question. Don't worry about that. Yes, we have got questions from here in previous years, right? Now, quickly tell me. So let's see the formula in general. So Bohr gave his model after he studied the whole spectra. So he gave his postulates, right? So what was the first postulate? Because yes, you can get the statement question from this portion.
The electrons revolves around the nucleus.
Hmm.
Is in the electrons around the nucleus is in fixed radius and energy.
Yes, that point is very important that the energy is fixed. Which point is important? Energy is fixed. Yes, energy will only be emitted and absorbed when the electron is going from one level to the other level, right? And one other assumption that he took is that angular momentum is the multiple of h upon 2 pi, right? Where n can be 1, 2, and 3, right?
Yes, ma'am.
Now, what did we learn? We learned about energy. So energy will be equals to minus 13.6 Z square over
N square.
square electron volt per
Square
atom. So write it in
atom.
joule per atom also, okay? Which I hope this we have done recently, so you must remember. Also, the one important thing that you must remember is kinetic energy is minus half of potential energy and total energy is a half of potential energy and kinetic energy is negative of total energy. This is basically total energy, right? Did we learn all this? Everyone, yes or no? Now, what else did we learn? We learn about the radius. What was the formula for the radius that we got? Because of course you can get as one Bhavna has sent her answer. So this question was simply based on what are these things proportional to? That is radius, velocity, and energy. Am I correct, Bhavna? So that question was totally based on the postulates. They were just asking about what is radius proportional to, what is velocity proportional to, what is energy proportional to, and that came in, I think, 22 or 21. Right? So that was the previous year question. So you can see that you will get question from here. So make sure you remember all of these. These should be on your fingers now. And that can only happen with revision. Again and again, I won't make you revise like this. But yes, it's the starting chapters. So I'm making it you do that. You have to do the same thing for you. Once the particular topic are complete, put it at one place. Yes, what is Rn? 0.529.
M
So
square by
yes, n square by z. Now tell
Z.
me about the unit. For me, formula is fine. Yes, the unit is
Astrom.
yes. Now, if somebody gives you in picometer, what should it be in picometer?
0.05.
That is in nanometer. Who was this? 52.9, right? So these are the small things which they'll confuse you with in the exam, and for sure they'll do that. But yes, keep all the things at one place. Done for the radius. So from here, what can I conclude? That your radius, it is proportional to n square by z. Can I write that?
Yes, ma'am.
Yes. Now the fourth thing is velocity. Now let's write the proportional with the, okay, let's write the formula also. So what is it? Hmm. Yes. Now I'll wait. You will tell me. Because anyways, you have to remember this. I already know all the formulas. Huh. What should I write here? Now you can unmute and answer this. No problem. Okay. What should I be writing here? N by z, z by n, z square by n square. What is velocity proportional to? No, unit is meter per second, but what is it proportional to? Okay, let's write the unit first. Ashrita wants us to write the unit, so it is meter per second. Yes, it is z by n. So what I can say that velocity in the nth orbit is proportional to z by
Z by N.
hmm. Now, what you have to do once you go back again, revise how did we do the calculation? Like what was the potential energy? As I have told you, it will be Q1 into Q2 over R. So all those formulas you have to see again, okay? Otherwise, it will take a lot of time. What else did we learn? We learned about radius, we learned about velocity, we learned about energy, and the other thing is time period, right? T is proportional to, and then yes, of course, we can write for the frequency also. So as you know, frequency is reciprocal of this. So yes, I can write for frequency also. With this, that's what we learned in the Bohr model, and this you must remember before we go into the quantum mechanical model. Yes, what about the time period? This is important. You have got question from this, which I have sent you in the group, right? Or we say time taken by electron to complete one revolution. What is it proportional to? Yes, Bhavna, Gayatri, Akshaya, Omkar, Shravani, Ashrita. What is it proportional to? No, it's not proportional to n. The answer is not that simple, right? The answer is not that simple. How can I write? Okay, tell me, how can I write time? Time is equals to distance upon velocity. So what is the distance that the electron is covering? The electron is covering, moving in a circle, right? So we'll take the circumference of circle, right? And circumference of circle is equals to 2 pi r. R we know, R is proportional to n square by z. N square, just say it again and again so that you remember this. Now in exam, what will happen is you will be confused whether n was in the numerator or was it in the denominator, right? So how can you remember this? So you know, as the value of n increases, the radius will increase. So it is directly proportional to n square, and then you have z. So this will be equals to 2 pi r upon velocity. Now I know what are these proportional. So now quickly see your notebook and tell me what is time period proportional to.
N square.
Is it proportional to n square? Is Omkar right? The answer that the Omkar gave. Okay, tell me who all are there in the class. Tell me whatever Omkar said, is it correct or is it wrong? So every day we'll not be spending time, this much time on again going through everything. It is expected that you already know all this, and the other important part is you remember all of it. Because if everything is evaporating as you are moving ahead, then at the end of the chapter you will be standing with nothing, right? So make sure you're doing the revision. And yes, you may get question from this portion, that is what is radius proportional to, what is velocity proportional to, what is time period proportional to, what is frequency proportional to. So you must remember all of the relationships. N cube and Z square. See, Bhavna, she is able to type everything, right? In 2 to 3 minutes. I hope you all can at least type your answer if you're not able to unmute yourself. Also, you can just simply put in the values in this 2 pi Rn upon Vn. What do I know? This is proportional to n cube by z, and V is proportional to z by n. So what I'll get? Yes, Omkar, what I'll get? N to the power? Yes, n to the power 3 and z to the power 2. Now, if somebody asks you for the frequency, it will be opposite of this, that is z square over n cube. I hope you all will remember this. Now I can ask you anytime. And from next time, if you are not sending the question, I'll ask ma'am and I'll not continue your session. Okay. So make sure you're sending the questions, answer to the questions. Take your time, solve them and send it. Okay. These are just 3-4 questions that you have to sit and solve. So yes, this is all that we have learned till now, which you have to keep in mind. That's it. This is the sequence of the things we have reached here. And then that's what Bohr said. Bohr gave all these things, right? That electron is revolving. So how does the Bohr model look like? So you have the positive charge, and then you have the electron which is in the fixed orbit. Now he was able to explain that point where Rutherford was not able to explain. According to his model, the electron should just fall into the nucleus, but Bohr added one more point that the electron they revolve in a fixed orbit with fixed energy. They will only lose or emit energy or gain energy when they are moving from one level to the other level.
That is
And
right.
that's how your Bohr atom looks like. This is the picture according to Bohr. I can't summarize better than this. I can't give you content more in a more systematic way than this. The more systematic it is, the more easy it is to remember in the exam, because right now you are dealing with three subjects. Right now the number of chapters will also increase with the time, so make sure you are doing revision. I'm emphasizing again, revision is very important. The only problem that most of the student faces, they don't remember most of it. They understand it, but remembering is very important for exam. Right? So that was the Bohr's model. Now, let's look at what were the limitations of the Bohr's model. So he was unable to explain the spectrum of atoms other than hydrogen. Right? Also, he was not able to explain when you are keeping a sample, whatever sample you had in a cylinder, if you are keeping it in a magnetic field, or else if you are keeping it in a electric field, right? What was happening? There was splitting of the lines that you see in the spectra. So in hydrogen spectra, the lines that we were getting, right? That's how we were getting the line. First, we were getting a red line, and then we were getting a green line, some blue line, and then violet line, right? So let's take this color. Okay. So that's how I was getting the line. So now when these were kept in the electric or magnetic field, there was splitting of these lines. These lines, they got split up, right? In the magnetic and the electric field. So he was not able to explain the splitting of the spectral lines. He was not able to explain the splitting of the spectral lines. And the splitting of the lines in the magnetic field is known as Zeeman effect. What it is known as? Zeeman effect. And the splitting of line in the electric field is known as Stark effect. So
Stark
just the
effect.
names are given to these. Splitting in magnetic field is Zeeman and Stark effect. So yes, as you go high into 12th standard or 11, you learn these things in detail in physics, right? We'll focus on whatever is necessary for us to understand what we are doing right now. And also he was not able to explain why atoms they form molecules by forming the bond. And the other thing you must add here, the third point, he was not also, he didn't give any explanation why did he take mvr is equals to nh upon 2 pi. So write it in your language that he didn't give any explanation to why the angular momentum is equals to the multiples of h upon 2 pi. Now we'll see further how did we come up. So he took this assumption and he gave his model. So most of his calculations were right, correct? But why did he take this? He didn't give any experimental proof for that. Like why did he was taking mv is equals to nh upon 2 pi? He just simply took angular momentum will be the multiples of h upon 2 pi. So these are the limitations of the Bohr model. So you can take the screenshot, write them. I will be asking them anywhere in the next or the next to the next class. So remember all of the things which you are doing in the class. These are the limitations along with whatever we have revised right now, right? Where is it? Yes. This also. This is what we have done till now, right? This is on one page. So I can't be more clear, direct than this. So one thing I am not liking is you people are not okay. What is Zeeman effect? Zeeman effect you are keeping the sample in the magnetic field and there is splitting of lines. So when you are keeping in the magnetic field, that effect is given a name, that is the Zeeman effect. Understood? So if you are keeping the sample in the magnetic
Yes, madam.
Hello?
Yes, madam.
Yeah, you can hear me?
Yes, madam. Now we can hear you.
Okay. Yeah. So the splitting of lines in the magnetic field is given a name, that is Zeeman effect, and the splitting of lines in the electric field is known as Stark effect. That is known as Stark effect, right? So I hope this all is clear to everyone. This thing should not happen again, that you are not doing the questions. At least send 1, 2, 3 questions, right? It won't take you much time. So I'm not very happy with the fact that none of you is sending the answers, right? Because that shows that you're not able to grasp what is taught, or I don't know what is the problem. So make sure that you are solving the questions and sending the answers. Also, if you have any doubt, you can send it to ma'am, and then obviously I'll take that doubt in the class. That also can be done if you're not able to attempt them at all. But anyways, we'll be discussing the questions also for sure. One complete session, we'll be doing all the questions that I give in the class, right? So I don't leave any question unsolved, right? But still, it's on your part that you try them once. Then only it will help you. So will you all be trying the questions that were given to you from now? You have to promise here and then you can only go today, right? So yes, how many of you will do that today? Just go through the questions that are given to you based on all of the things that are there. Or maybe you're not finding time, so make sure you're sitting on Sunday and just going through them very quickly. I think half an hour you can find to solve the questions, right? So I'm not very happy with the fact that none of you have sent any answers to any of the questions that I gave in the previous classes, right? Because it won't help if you will not do the questions. I'm being very clear, none of this will help. Whatever I am teaching, it won't help if you will not do the questions. So yes, Ashrita says she will be sending the answers. What about others? Yes, Bhavna, Gayatri, Omkar, Shravani. Will you all be able to send your answers by today, tomorrow, whatever, whenever you find time? Yes. So be excited, solve the questions, then only you will know how the content is relevant to the exam, right? So that's the only way you can excel in the exam and get good marks and be ahead of others, right? Yes. So, yes, make sure you all are sending the answer. Otherwise, tomorrow I am being very serious. I won't continue with the quantum mechanical model. And that model is very, very, very important. I can't emphasize more, but that's a very important model because there you'll learn about N, L, and all the quantum numbers, which helps in writing the electronic configuration, right? So make sure you send your answers. And this is what we have done till now. Today, I took time and revised it for you. and it took us so much time, but from next time you should be ready with this kind of a page from the previous topics, right? So this is all we have learned till now. So we have completed actually 3 models, right? This one, this one, this one. Now only we are left with the last model. And yes, you must be excited because this is something new which you will learn, right? So be prepared for tomorrow that we'll be starting with the quantum mechanical model. But before that, we learn about the development, similar to how we learned the developments for the Bohr model. And by the time passes, don't get confused between the things. That's why I am putting up things in a sequence, right? So this was for the Bohr. Then again, we learn about the developments for the quantum mechanical model, and then finally we'll move to the quantum mechanical model. So all of you make sure you solve and attempt the questions that are given to you and send your answer, ask your doubt. Otherwise, this all will not help. It will be like just going above your head. Okay. So yes, all.
Madam, you're not audible. Yes, ma'am. Prachi, ma'am, you are not audible. Okay, students, I think madam has lost due to technical issue, facing some technical issue. So, madam ఏమైతే చెప్పారో homework, please do the homework. Okay, at least try. మీరు ఏదైనా try చేస్తే కూడా you just send a photocopy that shows to madam that you people are interested. Okay, మీరు ఒక్క homework కూడా చేయకపోతే it is really waste of time. ఇంత మార్నింగ్ 5కి లేచి క్లాసెస్ మేడం వాళ్ళు చెప్తున్నారు, మీరు వింటున్నారు అంటే యూ హ్యావ్ టు ఫస్ట్ అప్రిషియేట్ యువర్ సెల్ఫ్, రైట్? ఆ ఎఫర్ట్ కి తగ్గినంత హార్డ్ వర్క్ మీరు ఎఫర్ట్ అయితే పెడుతున్నారు మార్నింగ్ లేవడానికి, అదంతా క్లాస్ విని హోంవర్క్ చేయడానికి కూడా యూ హ్యావ్ టు పుట్. జస్ట్ క్లాస్ వింటే మార్నింగ్ లేచి అది యూజ్ అవ్వదు ఇంకా. ఎస్ ప్రాచి మ్యామ్.
Hello.
Yes ma'am, you are audible.
Yeah. Yeah. Okay, then, ma'am, just make sure that you get the answers and send it to me. Then
Sure,
only
sure.
we can continue for this chapter because, yeah, make sure that they send the answers.
Yes ma'am, sure
Okay.
ma'am.
At least they attempt the questions. Getting the right answer is the other thing, but at least they attempt the questions.
Yes ma'am.
Okay, ma'am. Okay.
Yes ma'am. Thank you ma'am.
Okay, everyone. See you in the next class tomorrow.
Yes, students, I hope what madam has said you, at least madam needs you to attempt the questions, right? So please at least try to attempt the questions. Getting the answer, that is secondary. Once you try to attempt the questions, automatically your answer, one or the other day, you'll get the right answers, right? So everything will fall in its place when you work hard, right? So bye everyone. Again, we will meet in the evening from